Okay. Hydrogen peroxide is a pale blue liquid at high purity. Typically, it is used as an aqueous solution. It acts as a powerful oxidizing agent, antiseptic, and bleaching agent, readily breaking down into water and oxygen. Also, we can define hydrogen peroxide is colorless liquid and slightly more viscous than water. It is more hydrogen bonded than water and higher boiling point, that is 152 degrees Celsius, than water. The boiling point of water is 100 degrees Celsius. Hydrogen peroxide 152. Hydrogen peroxide has dielectric constant high and little use as ionizing solvent, so that hydrogen peroxide has high oxidizing property and it is decomposed by many metal ions. Hydrogen peroxide is first made by J.L. Denard in 1888. Sorry, 1880. Preparation of hydrogen peroxide. Hydrogen peroxide can be prepared by electrolysis. It is prepared by electrolysis of sulfuric acid or ammonium sulfate under high current density. Peroxodisulfuric acid is formed as an intermediate product, which is then hydrolyzed to give hydrogen peroxide. Sulfuric acid, peroxodisulfuric acid, peroxomonosulfuric acid, and again hydrolyze, it gives sulfuric acid and hydrogen peroxide. On industrial scale, hydrogen peroxide is now almost exclusively prepared by the auto-oxidation of 2-alkyl anthraquinone. Okay, on an industrial scale, hydrogen peroxide is now almost exclusively prepared by the auto-oxidation of 2-alkyl anthraquinone. The anthraquinone formed in this process is reduced back to anthraquinol with hydrogen in the presence of palladium catalyst for its reuse, the preparation of hydrogen peroxide. To ethyl anthraquinone, reduction of palladium to ethyl anthraquinone. Physical properties of hydrogen peroxide. Hydrogen peroxide, when pure, is an almost colorless, very pale blue, less volatile than water. The compound is miscible with water in all proportions and forms a hydrated hydrogen peroxide and water. Chemical properties of hydrogen peroxide: decomposition. Hydrogen peroxide is unstable and its rate of decomposition depends on temperature and concentration. Many impurities such as platinum, silver, charcoal, etc. catalyze decomposition. Okay, chemical properties of hydrogen peroxides. Decomposition. Hydrogen peroxide is inherently unstable and its rate of decomposition is influenced by both temperature and concentration. The decomposition process is also readily catalyzed by various impurities, including dust, alkali metals, and metals such as platinum, silver, and also charcoal. And it is dissociated into water and oxygen. Conversely, the addition of small quantities of certain substances such as calcium chloride, alcohol, glycerol helps to stabilize the solution and slow down the decomposition. These agents are known as anti-catalysts or negative catalysts. Oxidizing properties. Hydrogen peroxide acts as strong oxidizing agent in acidic solution. These reactions are often slow, but in basic solution, they are usually fast in acidic medium. Hydrogen peroxide reduced into water. The flowing reactions reflects its strong oxidizing property. Potassium iodide is reduced into iodine, ferrous sulfate into ferric sulfate, lead sulfide, into sulfur, potassium ferrocyanide. Okay, potassium ferrocyanide. Potassium hexacyanoferrate second into potassium hexacyanoferrate third. In case of hydrogen iodide, reducing to iodine, potassium nitrate, sodium thiosulfate. Okay, potassium nitrite into potassium nitrate, sodium thiosulfate into sodium trithionate. Reducing property, hydrogen peroxide acts as reducing agent when reacts with stronger oxidizing agent in acidic medium. Hydrogen peroxide is oxidized into oxygen. For example, potassium permanganate reacts with hydrogen peroxide in presence of sulfuric acid. Cerium sulfide okay, potassium permanganate reduced into manganese sulfate, cerium Pi sulfate into cerium third sulfate, potassium periodate plus 7 reduced into potassium iodate plus 5, silver oxide plus 1 into neutral silver. Acidic nature, aqueous solution of hydrogen peroxide acts as weak acid. It ionizes in water in the following steps. Hydrogen peroxide reacts with water, produces hydroperoxide ion, and also its peroxide ion. More simply, ionization of hydrogen peroxide in water can be represented as dissociation of hydrogen peroxide indicates that it acts as weak diabasic acid. Therefore, it can form two types of salt with hydroperoxides and peroxides. It reacts with base form salt. Hydrogen peroxide reacts with sodium hydroxide. Okay, hydrogen peroxide reacts with sodium hydroxide, sodium peroxide, also sodium carbonate produces sodium peroxide, barium hydroxide, barium peroxides. Structure of hydrogen peroxides. Hydrogen peroxide is linear and nonlinear molecule. The molecular structure of gaseous and crystalline hydrogen peroxides are significantly different. This difference is due to presence of hydrogen bonding in solid state, which is absent in gas state. This structure is also known as open book structure. In gas phase, in the solid phase. Uses of hydrogen peroxides as an oxidizing agent in the lab and in industry. It's a mill bleaching agent for silk, wool etc. as an antiseptic and as mouthwash. It bleaches black hair to golden yellow color and is known as auricome. 90% of hydrogen peroxide is important rocket fuel for restoring the color of black and lead paintings. Concentration of hydrogen peroxide. Concentration of hydrogen peroxide solution is generally expressed in terms of volumes such as 5 volumes, 10 volumes, 20 volumes. hydrogen peroxide solution etc. It represents the volume of oxygen obtained when 1 ml of that hydrogen peroxide is decomposed at NTP. For example, 10 volume of hydrogen peroxide solution represent the 10 ml of O2 gas evolved when 1 ml of the solution decomposed at NTP. 10 volume of hydrogen peroxides, 10 ml of oxygen is obtained by decomposition of 1 ml of hydrogen peroxide at NTP. 20 volumes of hydrogen peroxide, 20 ml of oxygen is obtained by decomposition of 1 ml of hydrogen peroxide at NTP. 50 volume of hydrogen peroxides, 50 ml of oxygen is obtained by decomposition of 1 ml of hydrogen peroxide at NTP. However, concentration of hydrogen peroxide is also expressed in percentage. Weight by volume, molarity, normality, gram per liter. Determination of concentration of hydrogen peroxides in gram per liter. Decomposition of hydrogen peroxide can be represented as hydrogen peroxide produces water and oxygen. From above balance equation, we can write the molecular weight of hydrogen peroxide 34, so 68, and 1 ml of the oxygen, that is the 22.4 liter, and 22,400 milliliter at NTP. That concentration of hydrogen peroxide is 10 volume. Now, 22,400 ml of oxygen is evolved from 68 gram of hydrogen peroxides. So 10 ml of oxygen is evolved from 0.0303 gram of hydrogen peroxide. Therefore, 1 ml of 10 volume of hydrogen peroxide contain 0.0303 gram hydrogen peroxide. And for 1000 ml, 30.3. So that gram per liter of 10 ml of hydrogen peroxide is 30.3. In percentage, 1000 ml of hydrogen peroxide solution contain 30.3 gram hydrogen peroxide. So that 100 ml of hydrogen peroxide solution contain 3.03 percentage. Concentration of 10 volume of hydrogen peroxide 3.03 percentage. In normality, let us first determine the equivalent weight of hydrogen peroxide. It reacts with hydrogen iodide H, produces iodine, changing of total oxidation number 2, so molecular weight of hydrogen peroxide 34. Equivalent weight of hydrogen peroxide, molecular weight over total change in oxidation number, so 17. So that normality, gram per liter over equivalent weight, so 1.79. So that concentration of 10 volume of hydrogen peroxide is 1.79 normality. In molarity, gram per liter over molecular weight, so 0.89. Number of moles in the 10 ml of 10 volumes of hydrogen peroxide. We have 1 ml or 10 volume of hydrogen peroxide, 0.030 hydrogen peroxide. So 10 ml of 10 volume, 0.303 gram hydrogen peroxide. Number of moles, weight in gram over molecular weight, so 0.0089.